is in three segments, like A0 to A1, A1 to A2, and A2 to A3. And for each segment, we have to just write like this is 1 1, this 1 1, this is 0 1, so this is 0 1, and this is 1 0, this is 1 0. And each time we have to compute the distance, we have to compute the Hamming distance between this individual code with the output, like 0 0. A0 to A1, the output is 0 0. So how much Hamming distance is there? It's basically 2, because there is 2 number of dissimilarity of the bits. That means there is a 1 1 is given, but here is a 0 0 0. So 1 0 and 1 0. So 2 transition, 2 dissimilarities are there. So that's why the Hamming distance is 2. Same A0 to B1. What is the output? 1 1. And what is the received code bit sequence? This is 1 1. So 1 1 and 1 1. So there is no Hamming distance. Same bits. So that's why the 0. Okay. Same as A1 to A2. For the next segment, we will consider 0 1. Okay. And we will compute again the Hamming distance between the received code and the output. So what is the Hamming distance between 0 1 and this output, like 0 0? So this is 1 again. Now when this is the output to be considered, that is 1 1. So what is the Hamming distance between 0 1 and 1 1? 1 again. Again, B1 to B1 to C2. So when the present state is B1 and the next state is C2, then the output is 0 1 corresponding to the input 0, because this is a bold line. This 0 1 is written above the bold line. So this bold line signifies the 0 input. So now we have to again compute that what is the Hamming distance between this 0 1 and 0 1. So this is basically 0. This is basically 0. There is no dissimilarities. Again for B1 to D2, this is 1 0 is the output, and we have considered this sequence of received code, that means 0 1. So there is 2, Hamming distance is 2. Okay, because here is a 0, here is a 1, here is a 1, and here is a 0. So 2 number of dissimilarities are there. So the Hamming distance is 2. So in this way, you have to write all the output corresponding to the input above the lines, above the directional lines, and then you have to just compute the corresponding Hamming distance between the received code sequence and the outputs. Okay. So again from A2 to A3, this is 0 0. So this is 1 0 is given. So there is a Hamming distance is 1. Now A2 to B3, this is 1 1. So this is 1 0 is given. So the Hamming distance is again 1. From B to D3 and B2 to D3, right? Okay. So now similarly, when the present state is B2 and the next state is C3, the output is 0 1. Okay. And when the present state is B2 and output is D3, the output is 1 0. Okay. So we have to just compute the Hamming distance between 1 0 and 0 1. So what is the Hamming distance? It's 2. And again 1 0. Between 1 0 and 1 0, the Hamming distance is 0. So because of there is no dissimilarities of the bit. So this is the procedure. So we have got all the Hamming distances with respect to the state transitions. Okay. So here it is written that you have to calculate the Hamming distance between received code and the corresponding state transition output. Okay. So as I've just shown you that first of all, you have to draw the code trellis diagram, considering this is present state denoted by A0, B0, C0, D0. Then the next state A1, B1, C1, D1. So first of all, the number of the bit sequence which you have received is 3, like 1 1, 0 1, and 1 0. So you have to make the table for 3 state, that means 3 segments. So first segment, the received code is 11, second segment 01, and the third segment is 10. Then you have to make this table port release diagram, and then corresponding to the inputs for the 0, for the 1, bold line is considered to be 0 input for the 0 input, and for the input 1 the dotted line represents. And basically you have to write all the outputs, okay, corresponding outputs from the table we have already made in the previous lecture. Okay, so then from each segment you have to compute the Hamming distance between all the outputs, all the individual outputs. Like for this segment there is 2 outputs, 0 0 and 1 1, and for this segment the received code is 1 1. So Hamming distance between this 1 1 and 0 0 and 1 1 1 1, so this is 2, this is 0, so you have to write in a bracket. So in this way, for the second segment this is 0 1, for the third segment this is 1 0. Okay, so that is the procedure. I hope you will understand. Okay, just let me erase it. Okay, so till now we have already got all the possible Hamming distances. Okay, so this is basically the paths. You can say from A0 to A3 this is a path, A0 A1 A2 B3 this is a path, A0 A1 B2 B3. So in this way these are all the paths. Okay, so at the next step you have to just calculate that all possible paths from A0 and path matrices. Okay, you have to determine the path matrix. So how to determine it? Very simple. You have to just add all the path Hamming distances. Like when you are considering A0 A1 A2 A3, this path. Okay, so then you have to add all the Hamming matrices you have calculated. Like from A0 to A1 the Hamming matrix you have calculated, this is 2. From A1 to A2 Hamming distance is 1. From A2 to A3 Hamming distance is 1. So the path matrix will be 1 plus 1 plus 2, so it will be 4. So like I have written all possible paths. So the first path is A0 A1 A2 A3, the straight line. Okay, A0 A1 A2 A3. Okay, so this is 2, the Hamming distance is 2, Hamming distance is 1, and Hamming distance is 1, so this is 4. Okay, so you have to just add all the Hamming distances. When you're following this path like A0 A1 A2 and B3, okay, A0 A1 A2 and B3, okay, this path. So what is the Hamming distance? 2 plus 1 plus from A2 to B3 the Hamming distance is 1. So 1 plus 1 plus 2. So this is again 4. So the next path is A0 A1 A2 B3. A0 A1 A2 B3. Okay. So in this way you have to write all the possible paths. The third path is basically A0 A1 B2 and C3. So you can follow A0 A1 B2 and C3. A0 A1. So this path's basically completed. Okay, from A0 A1 A2 A3, A0 A1 A2 B3. Okay, this we have just completed. Now the possible path is A0 A1 B2 C3. Okay, so always you have to look from the A0 to output. This is not output, but you can consider it as output, like a path. This is, we are starting from A0, and every time when we just go to the third segment. Okay, so You have to just